Welcome back. Last video, we deployed a single Kafka cluster, and today we're scaling up. So let's talk about the complete analytics pipeline. 9 nodes, 3 isolated networks, 1 Terraform file. So let's build a complete real-time analytics pipeline. First, the architecture. So here's what we're building. A 3-tiered data pipeline architecture where Kafka handles our streaming data at the ingestion layer, Kafka Connect acts as our data bridge with no custom ETL code needed, and ClickHouse serves as our analytics powerhouse for real-time queries. Each component runs on 3 nodes for high availability, giving us 9 nodes total across 3 separate VPCs, all orchestrated by a single Terraform file. So let's start with our Kafka cluster. In order to keep costs down, I'll use the T4G.small-5, but we do have support for much larger instances. The resource block tells Terraform to create an Instaclustr Kafka cluster, and we're calling it WR_Kafka_cluster so that we can reference it later. And inside the data center block gives us a completely isolated network from Kafka. We're running 3 nodes for fault tolerance on AWS Graviton processors, which are ARM-based and give us better price performance. This critical setting ensures your data is safe. The fault replication factor equals 3 tells Kafka to copy each message to all 3 brokers. So if your hardware fails, then your data doesn't. So now for ClickHouse, our analytics database. Notice how ClickHouse gets its own network at 10.6.0.0/16. It's completely isolated from Kafka. We're using Intel's instances with 8 GB of RAM and 50 GB of SSD storage. Perfect for getting started with real-time analytics. And Instaclustr also offers Graviton-based nodes, which deliver excellent price-to-performance ratios for ClickHouse workloads if you prefer the ARM architecture. The shards and replicas configuration is important here. With shards set to 1 and replicas set to 3, we have 1 logical dataset copied to all 3 nodes. This gives us fault tolerance now, and as your data grows beyond terabytes, you can increase shards to distribute the data horizontally across more machines. So let's talk about Kafka Connect, which is the data bridge. Kafka Connect bridges our systems without writing any custom code. The magic is in that target cluster block. See where it says Instaclustr Kafka Cluster v3? Well, that's Terraform referencing the Kafka cluster that we created above. This creates a dependency chain where Terraform knows to create Kafka first, then connect. Here's the race condition that this whole thing solves. Without this reference, Terraform might try to create connect before Kafka even exists, and then it would just fail. By using the Kafka cluster's ID instead of hard coding a value, we're telling Terraform to wait for Kafka to be created first, then grab its ID. So this whole thing prevents Connect from trying to start before it has anywhere to connect to. So let's talk about network security configuration. So the firewall rules control who can talk to who, and each firewall rule block opens specific access. The network field defines who can connect using IP ranges, and the type of field defines what protocol that they can use. That /32 means exactly 1 IP address, while /16 means the entire subnet. For ClickHouse, we need 2 access types. ClickHouse opens the native binary protocol on port 9000 for high-speed data ingestion, while ClickHouse Web opens port 8123 for running SQL queries in your browser. We're allowing both from Kafka Connect's network so it can stream data into ClickHouse. So let's talk dynamic outputs for connectivity. Terraform generates our connection strings automatically. This loops through each Kafka node, grabs its public address, adds port 9092, and joins them all with commas. So this is the same pattern for Kafka Connect on port 8083 for the REST API, and ClickHouse on port 8123 for the Web UI, where you can run SQL queries in your browser. So let's deploy with 3 commands. Terraform init downloads the provider plugins. Terraform plan shows what will be created, and then Terraform apply actually creates the resources. Terraform automatically handles the deployment order. Kafka first, then Connect, which needs Kafka's ID, and finally, the firewall rules, which need the cluster IDs. This dependency graph prevents race conditions where components might try to configure before the dependencies even exist. So to scale up, just change the numbers in your Terraform file, increase number of nodes for more Kafka brokers, then increase shards to distribute ClickHouse data, or use bigger node sizes for more power. So let's recap the key concepts. Terraform ID references create automatic dependency chains that prevent race conditions. Network isolation keeps each server secure, so that's why we used 3 different subnets. And then dynamic outputs mean that your connection strings update automatically as infrastructure changes. This is all defined as code, version controlled, and completely reproducible. And then in the next video, we'll configure the ClickHouse sync connector and stream real data. So we'll see you in part 3.